Welcome to World Around Us, where we bring you the latest discoveries and fascinating insights into our planet's natural wonders. In today's episode, we have an exciting update that will challenge our perception of the highest mountain on Earth. Scientists have recently made a groundbreaking discovery, uncovering a mountain that surpasses the mighty Mount Everest in height. Over the years of our planet's evolution, several historical natural wonders have formed. Each of these wonders has peculiar compositions, from the mountains to the oceans and volcanoes. Scientists have been studying these natural wonders in case of new developments. And a recent finding has just revealed the discovery of a new mountain. Upon analysis, scientists discovered that this new mountain is even higher than Mount Everest. Where is the new mountain located? Does it have a dangerous climate like Mount Everest? Join us as we explore how scientists just discovered a new mountain that is higher than Mount Everest. The way we see the height of mountains is different. These natural wonders can also be measured differently, therefore arriving at different height ranges for the same mountain. A mountain's elevation can either be measured over adjacent plains or above sea level. But it's not easy to measure a mountain towering tall at 29,029 feet. Mount Everest is the tallest mountain in the world above sea level. The mystery behind this mighty mountain's height has been solved since the middle of the 19th century, and it became registered in history as the highest point on our planet. As a result, when a discussion about the highest point on our Earth comes up, a collective agreement is made that Mount Everest is the highest point. And as a matter of fact, the narrative that Mount Everest is the highest point in the world has been engraved in the minds of humans so much that most people do not ponder twice before answering. And when conversations arise about huge mountains in the solar system, like Olympus Mons on Mars, we constantly compare them to Mount Everest. But even before this recent discovery was made, there have been theories that Everest does not actually hold the record for being the highest point on Earth. These theories have existed based on our planet's nature. In this aspect, we are talking about the shape of our planet. Earth is not shaped like a perfect sphere, but looks more like an oblate spheroid. An oblate spheroid is a type of sphere that protrudes from the center. These bulging areas are points that are located along the equator. When you give this theory deep thought, you will see that the mountain range of the Himalayas and Mount Everest find themselves a bit short. As scientists and researchers tried to get to the root of the matter, some recent measurements of the Earth were taken. The outcome showed that our planet has a polar radius of 6,356.8 kilometers, while its equatorial radius is 6,378.1 kilometers. In short, objects found along the equator are 22 kilometers farther away from the Earth's center than objects located at the poles. Naturally, there are a couple of deviations in the local geomorphology where objects located away from the equator are closer or more distant from the Earth's center compared to others in the same region. One of the most notable exceptions is the Mariana Trench, the deepest place on Earth, which drops to 35,797 feet below local sea level compared to Mount Everest, which is 29,029 feet above local sea level. However, the two geological features show a minor variation compared to Earth's overall shape, which is 0.17% and 0.14% respectively. In all honesty, Mount Everest is one of the highest points on Earth, with its peak mounting to an altitude of 8,848 meters above sea level. But due to its location within the Himalayan mountain chain in Nepal, some at 27 degrees and 59 minutes north of the equator, it is lower than the mountains in Ecuador. This area in Ecuador where the Andes mountain chain influences the land is where the highest point of Earth is. This highest point is the summit of Mount Chimborazo in Ecuador, only the 39th tallest mountain in the Andes. Mount Chimborazo wins this prize for being the tallest on the planet due to the Earth being an oblate spheroid. Due to gravity's pull on the Earth, the Earth's swelling is around the equator center. Mount Chimborazo, while not even close to the tallest mountains from sea level, sits confidently on this bulging equator and as a result is 7,096 feet further from Earth's center than the summit of Mount Everest. Situated in the middle of Guayaquil and Quito, Mount Chimborazo was originally an inactive volcano. It comprises multiple summits, namely Polytechnica, Wimpa and Nicolas Martinez. Wimpa is the highest point on the mountain. It's not clear how Chimborazo got its name, but according to some stories it is said to have been derived from a combination of the words Shingbu, which means women in the Kayapa language, and Razo, which is Quichua for snow. Basically, that would translate to women of snow, but natives who know the mountain refer to it as Carazo or mountain of ice. So those accounts might not be very accurate. However, it was largely believed that Mount Chimborazo was the highest mountain in the world until the 19th century, and many efforts were made to reach its summit. One such attempt included the French geodesic mission in 1746. Even though the team did not reach the top, their work affirmed the Earth's shape as an oblate spheroid. The map of Ecuador made in 1858 by Manuel Vicencio proves the information on the map assembled by this French mission and other early explorers, including Alexander von Humboldt. As a renowned explorer, geographer, cartographer and scientist, Alexander von Humboldt explored South and Central America between 1799 to 1804. He got to Ecuador in 1802 and tried to reach the top of Chimborazo. When the climbing party reached a height of 15,600 feet, most refused to go any further. Humboldt moved on with his traveling companion Amy Bonpland and an Ecuadorian companion, Carlos Montufar. Mount Chimborazo's peak reaches an altitude of 6,263.47 meters above sea level, but because it's situated at just 1 degree and 28 minutes south of the equator at the highest point of the planet's bulge, it has a natural boost of approximately 21 kilometers. When we compare Mount Everest and Chimborazo, judging from how far they are from the Earth's center, Everest lies at a distance of 3,965 miles from the geocenter. In Chimborazo's case, the mountain reaches a distance of 3,967 miles, leaving us with a difference of 2 miles in the measurements. Even though the difference does not seem much, it is vital to be factual when discussing titles and rankings. Despite this analysis done by scientists and researchers, some would still stress that Mount Everest is still the tallest mountain on Earth. However, even though it is measured from base to peak, these sets of people would be incorrect. The tallest mountain in the world, if we are being factual, is Mauna Kea, a dormant volcano on the island of Hawaii. The mountain measures 33,484 feet from its base to its peak, therefore winning the prize as the highest mountain in the world. Unfortunately, we only get to see a part of Mauna Kea, as its base is several thousand meters below sea level. This leaves us to only admire its top, which spans up to 13,802 feet. However, if one were to say that Everest was the tallest mountain due to its altitude, one would be correct. Regarding its summit elevation above sea level, Everest is ranked as the tallest mountain in the world. But how are these mountains measured? Of course, measuring mountains is not an easy task, especially when we go back to the 19th century. It must have been tough. Still, how was it figured out? GPS didn't exist then, and altimeters were also not completely accurate. So getting this basic piece of information about our Earth's geography must have been a struggle, as it required thousands of person-hours, a lot of trigonometry, and nearly 100 years to achieve the actual measurements. Measuring Mount Everest started with Sir George Everest's successor. His successor, Andrew Waugh, was the one who commissioned a wide-ranging survey of the Himalayas. As they began to measure Everest, surveyors utilized the triangulation method. The triangulation method was done by observers checking the peaks by several points, figuring the distance from the points to the mountain. They were then able to calculate the angle from Everest peak to their observation points. But in order to measure the sea level, the observers had to figure out their own elevation above sea level. Given the angle and distance, basic trigonometry was used to get the mountain's height relative to the observer. Unfortunately, Waugh's team encountered issues with atmospheric angle, or the bending of light over long distances as it goes through several air densities. Refraction brings about a mirage-like effect, which can make objects seem to be shorter or taller than they actually are. It gets bad over long distances, and other form factors made it worse. One such factor was due to political reasons, which stopped surveyors from moving very close to the mountain. Due to these issues, most of Waugh's observations were done from more than 100 miles away. Despite this hindrance, the surveyors were able to come up with an incredibly accurate measurement of 29,002 feet. The mountain went on to be measured multiple times for the next 100 years was to confirm this measurement. When access was eventually granted and close measurements could be conducted, 27 feet was added to the mountain's height. In our modern-day world, the process of measuring altitudes and arriving at an accurate outcome has been made easy with the advent of satellites and GPS. However, one problem still remains: some of these mountains do not remain constant. With an example of such mountains being the Himalayas. The Himalayas were created due to the ongoing collision of the Indian plate with the Eurasian plate, making the range remain very seismically active. As a result, frequent earthquakes affect elevation. Some quakes have minimal impacts, such as when a landslide removes a few feet of rock from a summit. But movement at fault can quickly surge elevation by as much as 5 meters. As a result, entire portions of the range are rising every year. However, there are also other concerns. For example, scientists and researchers ponder if snow and ice are part of a mountain's height. This is why including the measurements of a mountain's peak can be very tricky. But assumptions can only mean little on an ever-changing planet. Nevertheless, these mountains have been a center of attraction for scientists, researchers, geologists, and even adventurers. And it's guaranteed that they will continue to fascinate us for a long time to come. Let us know your thoughts in the comments section below. Mountains have always captivated scientists, geologists, and adventurers alike. Their exploration continues to inspire and intrigue us. Stay tuned to World Around Us for more updates on our planet's extraordinary natural wonders.